gloves on. As you can see, it works. I mean, it moves. I put some tape on it to protect the metal so it doesn't scrape. What we're gonna do is we're gonna bend that. That's about, what is it? It's actually shorter, yes, it's not 2.5. We can check it. We can check it. It's about 1970 millimeters. Let's mark it 60. Good enough for our. We're just building shelves from scrap. So the accuracy is fine for us. We can actually see the line here. With tape it's always hard to see the line. Without tape it's quite easy to see. The tape also doesn't hold as well, so I usually use clamps, like metal, extra. I don't remember what they're called in English, but we use the clamps so it stays still better. Otherwise it might slip a bit. Now these, I usually preload, and when I'm not using it, I release the tension. Currently it's chill, right? What it does, it actually makes that bend, make it turn a bit. That as well. So this is the underside of it. About how much, it's like, I'm gonna get used to it. Depends what you're bending. Wait, which way? This one. We don't need that much. That's good. And now, there we go. It always takes me a second which way to turn. But also I know that that's 16 times 60, so I could just use the outer edge for accuracy, which we're gonna do. Sorry, I can hardly feel it squeezing a bit from the middle. Let's say we tighten it. We don't have to go too heavy. But I was saying the cost of that tarnation. This is also extra, like I just some leftovers. That table is not included. This is weird ass table with 5-6 meter I-beams that I actually planned to use for the roof, movable roof, but I didn't like how much headroom I'm losing, so I was like, nah, I'm not gonna do it. Let it be. So now it's my weird table. It's actually a surprisingly useful table, I have to say. I usually make it tight, not because I need to make it extra super tight for it to bend. I'm making it tight so it doesn't slip. Wait, supposed to be this way. There we go. There's one example here of a successful bend, successful overbend, as the product might suggest. This is actually quite 90, almost 90. That's like 2-degree overbend. This is like 15-degree overbend. But as you can see, the radius is quite nice. There was what was radius? Yes, 13. Radius 13 was the bend radius of that. I on purpose made it smooth, not especially, for two reasons. You can bend thicker material easier because it takes less force. I could install like extensions and then add some weights on top of here, so if I pull it up, the weight go down, it makes it easier. But I don't feel like it. I like to It was made cheap on purpose. You could use some more material. As you can see, I don't have to weld like crazy. Tack welds here, tack welds there. Some welds here, some welds there. Don't need to go nuts. Some welds here, too much welds here, some too much welds here. But in general, not too crazy. I bent this as well, as you can see. This is not very thick, but it's like 3 millimeters. But yes, made, where's my lamp? I need a lamp for that. Made that inside piece here. That's actually where that is from. That's like, that was 2.5 meters long when I bended it. Bended it. That sheet metal has bent under here, as you can see, all the way. That's also like a bit less than 2. 1.5 millimeters, same as that other one. Has these curves, this inside bend, and that's what I was building it for, to make these types of bends. Mostly for 1.2 and 2 millimeters, stuff like that. Thinner you can go. The less width. It's weird to pronounce it. If it's not that wide, the piece, then you can go thicker, but you also have to bring it tighter. So this way, this. And bigger ones usually want to be close to the edge. It's very simple design. I didn't want to use any bearings. There's actually regular pipe, regular thick wall pipe with round steel. It's pretty dirty right now, obviously. It's been here for a while, been a lot of use. It's good. And I see how nicely these move. Maybe add some more oil. I actually put oil in here. But these are just to make sure there's no free blade, so it's in the center. Like for our accuracy, it's very good. We don't want to go completely nuts. But yes, when it's too tight, what's gonna happen is, or too small edge, it really wants to push it away. But that's not I wouldn't say it's a downside of that machine. It's this bending table is mostly the downside of holding on to the piece. It's hard also, I've seen even big machines with the proper ones, it's really hard to hold on when to move tight those. So it's like if you tiny tack weld, like let's say I have steel here, I just put, these are free, I can just move them around if I want. This is temporary solution, these things, temporary fixes that work for a long time. But yes, let's bend it. I'll show you. It's not actually that hard to pull it. It's not that heavy. It does take a lot of force though. So you have to be like, fucking hell. Wait, warm up. Fuck. I was just messing with it. You know, it's quite easy. I like to go like that. As you can see, we did overbend it a little bit, maybe. Let's have a look. It's pretty much 90-ish. Because we're doing 1.5. Where's the light? Maybe you see better with light. Yeah, as you can see, I usually make sure the middle is correct, and then I unbend or overbend with the hand here. It's because the metal in the middle is fighting the most. That's why we're also using those to preloads. But in the corners, only one side is fighting, so it's easy to overbend that. So you go to some distance, this guy fights back less, and then that's why usually I overbend 90, let's say, and then overbend again. That's usually how it goes. And that happens with every machine. You can put the ones that the punch bend, or they have the punch and a die, and then it just goes in. And the long ones, even like that, it's just gonna have the same problem. You're gonna have the middle move a bit. But with these, you can actually preload and actually make them those long ones a lot straighter. Obviously, it's no match to the punching machine of having like different tools, like different distances. But that's like $80 if I finally. Wait a minute, which way do I do it? Yes, in is loose. Keep forgetting. You can use pipe too, but I like to use that left. So I need to lock it to release it. I always forget it. Could have used. I was a bit in a hurry. I didn't have time to order reverse threads and reverse thread nuts. So now I'm just struggling. It's my life. It's already loose, but give it some more space. The bird has been pooping here, nice. Ain't that lovely? See, we take it out. It's very nice. I know I keep saying it, but it is. If you look it straight on, you can see a slight. Maybe we would have preloaded a bit less, more. I don't understand. A bit more, slight more preload. It would have been perfect. I'm not looking at the outside. I'm looking at the inside corner towards the light. I know it's very not lighty here, but a bit dusty as well. It's hard to say. Dust kind of makes it weird. But no, it's pretty good. You can use a straight line to test it, whatnot. Of course, this way it's flex, but we're gonna use it. It's gonna go on a shelf. Elf on a shelf. It's gonna go like that. Just gonna tack it in, and that's gonna be our. And then we can use other sheet metal to put it like that, other way, and then just probably tack it that as well to make it nice. Let's have a look. Just a scrap metal. I don't need it anymore. I mean, I could use it for some other things, maybe, perhaps, but look. We're just gonna put like that. Boom. And then the other side we're gonna do under bend. And we have to make sure that because it does bend quite sharply, but I mean accurately. We can calculate the distance. I'm not very sure, but it should be like 64 millimeters right now from outside to here, if I remember correctly. And if you do the outer bend, we have to make sure it's longer, so you can still make that. If I make it too short, then I would have to start cutting those. It's good for the shelf, I would say. Let's not scrape the bus with the back, and we can measure it. Right now, our caliper is somewhere else. Let's do it this way, easy to see. Oh no, I messed up. It's 65, not 64. Yes, that's 60. That's 64. But yes, it's about 80. I would say 80 euros. 1.5 euros was kilo. The price of metal. Bit of weld, nothing crazy. I will have the technical drawings on Patreon if you're interested. But if you're interested, you can have a look. You can build it yourself. It's fun. It's easy to build. It's works good. It works pretty nice. It's quite light.